Yes, I am. My name is Pascal Ruffieux. I just gave a presentation at the Heteronanocarb conference, and what I wanted to convey you is that carbon nanostructures offer a very wide field of properties. So there is literally hundreds of papers that have been discussing a very wide range of physical properties that can be accessed if we should be able to manage basically the atomic structure of graphene nanostructures. So the problem is to really reach this goal is to synthesize these structures in an efficient way so that we can basically maintain the atomic precision that we know that chemists have been attained since hundreds of years in a larger scale, so that we need to improve the range of size while keeping the atomic precision up to hundreds of nanometers. So the way that we chose to do so is basically using a bottom-up fashion of fabricating these structures. So meaning that we take basically building blocks that are atomically precise, made by chemists, and choose a specific linking pattern so that these structures can be brought together to make a larger structure while maintaining the atomic precision. So basically this allows us to keep the properties which are designed at the very atomic level by defining edges or specific width of the carbon nanostructures and bringing them to a larger scale so that we can basically contact them and make a bridge to existing contacting procedures, and finally maybe integrating them into devices that can basically benefit from the properties that have been designed at the very bottom of these carbon nanostructures. So the basic task is to define these building blocks which are selective enough to really reach the pattern that we aim for. So basically designing these molecules together with the chemists, and then designing also an activation procedure so that we can put these structures together piece by piece on a surface to yield the final target structure. So basically the missing piece in this road is basically our eyes. We cannot see what we are doing, and therefore we rely very much on scanning probe microscopy. So the method that we use is scanning tunneling microscopy, which allows us to see individual molecules and to really track basically the procedure in the way how these structures are built up. So basically we can analyze all intermediate steps of the growth and decide whether really the target pattern has been achieved at the end. Using the same procedure, we can then also analyze these structures. So we don't just analyze the structural properties, but we can really access the electronic structure in the end by using scanning tunneling spectroscopy to really see whether the target properties that have been the motivation for deciding for one structure has really been achieved. So our main motivation initially was to target for structures with a finite band gap, so overcoming the barrier that graphene is facing, which is a semi-metal and does not have a band gap, which is needed for a number of applications such as transistors, which can be efficiently operated and we would like to operate them at room temperature. So we need a sizable band gap, and by confining the structures to below 1 nanometer, we can achieve these properties and then really decide also based on the spectroscopy whether we achieved the target goal. So basically it's a field that is linking computational science that is considering the properties of a specific graphene nanostructure that we aim for, and then designing basically the molecules that would allow to grow these structures at the surface. And then in the end, basically surface science to really say whether these structures have been achieved and to also characterize them directly on the target substrate or after transfer on a more useful dielectric substrate. So it's bringing together a number of fields as is generally observed in nanoscience. It's not a discipline by itself, but it's bringing together competences of different fields which need to be worked at a very high level to really reach the target structures and to characterize them in the end. So the current status of the project is that indeed a number of different well-defined carbon nanostructures can be achieved. So we are mainly working along graphene nanoribbons, properties where we can define or choose different band gaps or even specific edge states that are predicted to be spin polarized. And to reach a quite wide range of properties that is accessible so far. So the current status is that these structures are formed and that they also can be transferred to more useful substrates such as dielectric surfaces, where in a next step devices can be envisaged. So we have initial devices that are basically showing that these achieved electronic band gaps allow for an efficient transistor build-up. So this is a crucial step that we have been putting forward at the very beginning as a motivation of the project, and this is one of the goals that is currently available. So the future will bring a number of different aspects, so there is certainly room to further broaden the different structures to achieve a wider range of band gaps available in these structures. There's very interesting physics related to more zigzag edge related features such as the mentioned spin polarized edge states, which are quite a challenge in the synthesis, but also in the way how this material has to be handled in the next steps. So there is some protection issues that need to be solved, but this is a current target of research, and that's where main activities are going on. So as the name of the conference says, there is even richer properties that can be envisaged if you go for heterostructures based off these graphene nanoribbons. And there is certainly a main challenge to really control such heterostructures in a fully selective way, meaning that we put together pieces of different types of graphene nanoribbons in a very well controlled way, so that the final properties of the aimed heterostructure is really as predicted by computational science. So this is the field that has opened quite a bit. So there is currently a number of groups that are working along these lines, and the research currently has gained quite some momentum. So we look forward to see a quite rich future along these lines of graphene nanostructures.
Thank you very much. Terrific. Terrific.
Yes, I think.
Are you happy with that?